Okay, Evangelina makes a one-time deposit of $1,000 into a savings account with an APR of 4.6% compounded monthly. How much will be in her account after 4 years, round to the nearest cent? So if you need the notes about the formulas, that's the wrong page, but it's the right formulas. Um, you can access those by going to the quantitative reasoning page on the SSC's website, go to our chapter 4 section, notes and examples, and there's basically everything about chapter 4. First page is just what the different variables are, so you definitely want to know what these are if you're going to use these formulas. We have what looks like a compound interest account. I have that keyword compound, so and it's a savings account. There's no mention of a loan or anything like that. And it's not an IRA, it's a one-time deposit, so that makes me feel pretty comfortable using the compound total accumulated amount for compound interest right here. So we're gonna use this formula. All right, so let's start writing the different pieces down. Where's my pen? There's my pen. Okay, so this is the formula. A equals P times 1 plus the periodic interest rate N times Y. So lots of times with these questions, I like to write off onto the side what the different pieces are. A stands for the accumulated amount or the future value, and that's what I'm looking for. How much will be in her account after 4 years? So I do not have A. So let's go on to P. P stands for principal, or the starting amount, or the deposit amount. And Evangelina deposits $1,000, so that's P. Let's see, in the formula, the next part is a 1. That's always a 1. R stands for the periodic interest rate, which is the same as the APR divided by the frequency of the compounding. And in our case, the APR looks like 4.6%, which in its decimal form is 0.046. And how often we compound per year? It looks like we compound monthly, and there are 12 months in a year. Which brings me to the next part of the formula, the little n. Little n is how often you compound. That looks like it was monthly, so 12. And then y is the number of years. We got 4. So I like to write all these down and then plug them into the formula. So P is 1,000, 1 is a 1. My periodic interest rate, 0.0046 divided by 12. Now you can do this division first if you want to. Very rarely are you going to get a number that you will not have to round. And we usually want to round these at the very end of the problem. This one says round to the nearest cent. If you try to do this 0.046 divided by 12, you're not working with cents and we would be rounding, and it's not good. Not good. So actually what I'm going to do is use the Desmos scientific calculator. It's free, available online. And I'm going to basically put this entire equation into Desmos all at once. It's going to avoid rounding until the very end, which is good. Okay, so I'm going to start typing things into Desmos, basically just how I see it. So I've got a 1,000. I've got parentheses, 1 plus, and then I've got a fraction, which is the same as division. So 0.046 divide by, and look, makes a fraction for you automatically. Cool. If you are done with the bottom of the fraction, you can use one of these arrow keys over here to get out of the fraction, which I'm going to do. Next up, I see parentheses, and if you have an exponent, which we do, you're going to press the a to the power of b, this button here. And ours is 12 times 4. And there we go. This avoided any unwanted rounding errors by putting the entire question into Desmos all at once. And we can now take this answer and round it to the nearest cent. So it looks like Evangelina has $12,001.59. So they ask us how much will be in her account after 4 years. There it is, 1,000. Should I say 12,000? If only. $1,201.59.